Hello everyone, welcome to Tech Academy. My name is Tahira and I'm excited to have you here. If you are passionate about tech and eager to learn something new, you are in the right place. Today I'm kicking off an exciting new series on SQL. Whether you are a complete beginner or looking to refresh your skills, this series is designed to help you master SQL step by step. So let's begin and understand what exactly is SQL. Before that, I'm assuming if you are here, you would have come across SQL at least once. And even if not, do not worry, we will look into this. SQL stands for Structured Query Language, and it's a standard programming language for storing and processing information in a relational database. So for now, if you don't understand what a database is, do not worry, we will look into it in a couple of minutes. Now, coming back to SQL, SQL is a special language we use to talk to database that stores a lot of information. You know how you might use Google to search content on the internet? Well, SQL is similar to that, but it is used to search and manage data in the database. So, whenever a website needs to store information like user account details, shopping cart items, search history, etc., it uses SQL to organize and handle all that data. You can think of SQL as behind the scenes helper that makes sure everything is in the right place and easy to find when you need it. Let's understand what is a database. But before that, let me break down the term into two parts, data and base, and understand this individually. What is data? Data refers to facts, figures, and other pieces of information that you come across in your day to day lives, which can be processed or analyzed. It can come in various forms like text, such as names, addresses, descriptions, in the form of numbers like prices, quantities, salary, in the form of images and videos. In essence, data is any piece of information that can be stored and processed. What is base? In simple terms, base is a foundation or a central place where things are stored and organized. In the context of a database, the base is the central location where data is stored and managed. You can consider library as your centralized location where books are stored. Similarly, you can consider servers, cloud storage system as your digital base where the data is stored. Base refers to the structure or system that holds the data and provides a way to organize and access it efficiently. Now that we have seen what data and base is, I'm sure that you have got a bit of idea of what exactly is a database. A database is a structured collection of data that is stored electronically and managed by a database management system. It combines the concept of data with a base, resulting in a powerful tool for organizing, storing, and retrieving data efficiently. To better understand this, let's take an example where we can simply compare our database with the registers. Imagine you are running a small shop without computers and just using registers to maintain information about product, customer, and order. In order to maintain this information, you need to have separate notebooks for product where you maintain all the details about the products like name, price, description, buying cost, etc. And customer registers where you store customer information like their name, addresses, gender, contact details. And then order register where you record each order, which customer bought, which product, and when. This is also a form of storing the data. Database is similar to your registers, but it is an upgraded version of the registers where you store data digitally in the form of tables, which is the core component of a database. So in case if I want to store the information about products, customers, and orders, then I will have three separate tables like product, a table, customer table, and order table. And each of this table is made up of rows and columns. So the rows are the horizontal lines where you have information about a particular product, for example, and the columns are made up of specific details of that product. Like, for example, I'm talking about laptop, right? So all the details of laptop is like stored in horizontal line, and specific details about laptop are stored in the form of fields like columns, like product ID, their name, price, description. Now, let's understand why do we need databases when we can maintain data in different file formats. One of the example is data storage. Database provides a structured way to organize and store data. Normal data storage like registers, flat files like Excel or CSV stores data in a simple unstructured format. So without database, data would be scattered across different files and formats, which makes it difficult to manage and retrieve, like you saw in your register, right? If we want to retrieve some particular order, it requires a lot of manual searching and sorting, which can be slow and inefficient. Whereas databases uses SQL queries to quickly retrieve and manipulate data. Another advantage is data integrity. Um, it ensures data integrity ensures accurate and consistent data entry across the tables. What I meant by this is, for example, if you're maintaining register and you're entering some information about order, so there are chances that since it's a monotonous job, you might miss out the customer name or the quantity they bought. But the data integrity enforces the data, enforces to add some constraints like the unique keys for your customer email ID. So no two customers can have the same email ID. So whenever you enter the same email ID, which is already existing for any other customer, it will give you an error that this is a duplicate email ID and it will ask you to enter another unique email ID. And also, for example, for the employees table, if there's a column called salary, the salary cannot be like zero or null, right? So you can add a constraint that it cannot be null. Another advantage is concurrency. Normal data storage does not handle concurrent access, whereas databases allow multiple users to access and modify data simultaneously without conflicts. So to better understand this, as we were talking about registers, like if there are two people, me and my friend who wants to get some information about a particular order. I want to get information about order one, and my friend wants to get information about order two. We cannot use the same register at once, right? We cannot use it at the same time. But database allows you to access and modify data simultaneously without any conflicts. Now let's move on to understand what is DBMS. You can think this as a software tool that helps us to store, retrieve, and manage data efficiently. Imagine you have a digital library with thousands of books. A DBMS is like a super librarian that helps you find, organize, and manage those books easily. Now, you would have come across some people use the terms DBMS and database interchangeably, but they are not the same thing. Database is a structured collection of data. You can think it as the storage place where all your data lives. Whereas DBMS is the software that interacts with the database. It helps you to manage, organize, and retrieve the data from the database. To better understand, let's take a look at this diagram illustrating the interaction between application, DBMS, and database. And let us consider a flight booking scenario to have a better understanding of the interaction between these three. The application layer, which you see here, is the website or the mobile app the user uses to get information about the flights, like the user input details such as departure city, destination city, travel dates, and passenger information. And then when the user sends a request, DBMS will receive this request to search for available flights that matches the user's criteria. Then the DBMS processes this request and performs a query on the database to retrieve relevant flight information. This database contains tables such as flights, airline bookings, passengers. Then the DBMS retrieves this data from the flights table based on the search criteria like departure city, destination, and travel dates. Then the DBMS will process the retrieved data and send it back to the flight booking application. Now, the user decided to book a flight. The application again sends another request to the DBMS, and it will create a booking record in the database. The DBMS will update the bookings table with the new booking information and links it to the appropriate flight and passenger records. It will also update the flight table with the flight seats. Then the flight booking application receives the confirmation from the DBMS that booking is successful, and it will display the booking confirmation and details to the user. Now let us see the different types of DBMS. Each of the DBMS is designed for specific needs. For example, a relational database where we organize data into tables with rows and columns like a spreadsheet, and it uses SQL for data manipulation. Some of the examples of relational DBMS is MySQL, PostgreSQL, Oracle, Microsoft SQL Server. And another form of DBMS is NoSQL DBMS, which is designed for unstructured or semi-structured data. And it supports various data models like document, key value, column family, and graph. Examples of NoSQL DBMS includes MongoDB, Redis, Cassandra, Neo4j. Thank you for watching. See you in the next video.